So I'm just going to reintroduce myself just in case everyone wasn't here this morning. So my name is Rob. I am a startup solution architect, and I spend most of my time in London working with the startup community there. Most recently, I've been working with a lot of the earlier stage startups and the early stage VCs, angels, and incubators. And I really love working with this group. Like the energy and the type of work that they're doing, the speed they operate at is fascinating. Possibly one of the most common conversations I have is kind of what we're going to go through here today. And that is, how do I build my MVP? What is the correct tool or the approach to put into this? So I won't just frame it around technology only, because we all balance technology and our business or startup needs together. And also, if you like, there's no singular right way to do something. But I want to introduce an approach or a set of tools that you may have not used so much before that I think you can move really quickly with and iterate on with. Happy to take questions. Probably best if we kind of stack them towards the end. And I'm going to be around afterwards as well if we don't get a chance then. Okay. Cool. So this, if you like, if trying to write this down, this is about the closest I can get to an MVP process or startup process. You've got a hypothesis. If you don't have a hypothesis, you really should have a hypothesis. It's all really well building something because you can, but what you want to know is what is the right thing to build? What do my customers care about? Also have a really tight and measurable hypothesis that's clear and defined. And then you need to build this. And ideally you want to build the minimum possible to disprove that hypothesis. If you can't, then you keep going. And then you're going to need to measure it. You can't disprove or prove something if you don't measure. Oh, I apologize. Yeah, absolutely. So an MVP is a minimum viable product. So I'll refer to it as MVP during the talk, but thank you. And this, let's define that exactly as well. So minimum viable product, each of them words is super important. You should build the smallest thing that you need that creates something that is usable for somebody and is still actually a product. Okay? And it could be referred to in slightly different ways. It could be MLP. So your minimum lovable product. But the whole concept is the same. Something that is small, you shouldn't need to build everything to get to the something usable for somebody. And it needs to be important and valuable for them. And it needs to actually be a product. It can't be you chasing around trying to do everything. Once you've measured, you'll start to learn and iterate. And as you iterate onwards, you will then start building and altering that first phase. If you like, that build phase, measure, iterate, is continual. You'll keep going round and round and round. And although we've put scale at the end, in reality, it's best to think of that as a build, measure, and iterate phase. There's no real distinction between it. So if we talk about the hypothesis first, and think about the clarity of what you're trying to achieve. So when you're trying to measure something, you want something that is singular and within your aim. I speak to a lot of startups, and when they tell me, when I ask them what their benefit is, I get a list. It's always good to start with a really clear and singular mission, something that you can deliver that is really crisp to your customers. And you want to make sure it's measurable. If you can't measure it, you can't know if you've succeeded against your metric. You might not know what the right value to get to is, but if you need to have a measure so you can understand at least where you are in relative terms. As well, the hypothesis is incredibly important for you to frame what your business is around. So let's take a little look at the approach of how you think about your hypothesis and MVP. So if you kind of imagine this pyramid of a stack of what a product is, like this is what you want at the end. You want everything colored in, everything completed, to be usable, valuable, reliable, of course, to scale, and to be a great experience, or to be beautiful for your users. Now, I spend a lot of time with people building MVPs, and we all tend to take one different slice of them and build them out. So are there any designers here? Okay, cool. So there's a very good chance you would start with the top. You would have an incredibly beautiful MVP. Any engineers from an infrastructure background? You would have an incredibly scalable product. So if you're from site reliability engineers, it's going to be reliable. Some engineers that maybe operating more on features, it's going to, well, on the business side, if you get that proposition right, it'll be really valuable. And engineers that are more on the feature level building applications, you'll make it really usable. And the question then is, well, which one of these do I do? And I think the simplest way to describe it, if you focus on one of them, you don't want to go super wide. You want to actually touch on all of them. So imagine this as an approach. You need to have, your MVP needs to address a certain slice of everything. So that's why it's good to think about what is the minimum feature that's going to be really important to allow you to be able to build that exact thing. So if we were building an MVP and we wanted to get to a car before a car was invented, it's better to have something that flows and can be progressively useful as you go on. So each one of these phases could be considered a product. If your car, to get there, you needed to build an engine, and the steering wheel, and the seats, and then the wheels, every phase of completion, you wouldn't have something useful. Whereas here, I can get to A to B with the first phase, the skateboard, the scooter, A to B again, the bike, the motorbike, the car. I can still achieve that same goal that you were trying to do. Your vision, bring someone from one place to the other. It gets better and better over time, but it still has a minimum valuable or viable product at each stage. So let's make that more concrete and think about what we would do or how we would do this in a technology type terms. So with 165 different services, there is a lot of different ways of building an MVP. And in all honesty, like if we had like a too long do not read on this presentation, it would be do whatever is going to go the fastest for you. One of our new recent releases is Amplify. And I think in many ways, this is a new approach and really focused on building mobile and web applications to get there as fast as possible. So I'm going to spend a little bit of time explaining what this looks like so you get a bit of an idea. So it comes in 4 different components. You have your framework, which is what you download on your computer. And this is kind of like how it all sticks together. The cloud services. So of course, these are the different services that stick behind it that make it work. The development tools, all that extra functionality for developers so you don't need to build what you're always building. And the CLI itself. So the way you interact with it, you can do everything through the CLI. So if we talk about the framework itself, it's a framework for building both mobile, web, and even API applications. And that covers a large majority of what startups are building, at least on the presentation layer for their business. From the mobile point of view, it supports multiple frameworks. So you can build inside of iOS, Android, web, or React Native. And then you have different APIs. So you can have a normal REST API with API Gateway, or you can use GraphQL, which we'll dive into much more detail later on. So this has a really nice sort of ethos. And the idea is it's meant to be easy to use. This is for developers that actually come from more of a front-end background. You don't necessarily need to know how things work. So the library is easy to use. And the tool chain, or the API that sits behind it, is actually, think of it like this. It's like having a world-class operations team inside a CLI. So you can, as a front-end engineer, or someone working on an API, be able to rely on the underlying services. They get created with all the best practices that we have. You're then able to dive deep and understand and unpick everything, but you get started really quick. And of course, we want to make it usable and beautiful for our users. And it comes with a lot of UI components and UX flows that allow you to quickly get together a application or website that looks desirable and makes sense for your users to use. So we have been developing a lot in this space. So it's actually built as an open source JavaScript library. So you can go online and actually look at Amplify, the tool chain. You can see everything there. It solves a couple of really difficult problems. And one of them is offline data. So if I'm building an application and I don't have a stable connection, perhaps that's because I'm going on underground or in disconnected parts of the country or even the world or on an airplane, it allows you to operate offline and then sync the data afterwards. That's all taken care of for you. And real-time data. If I'm building a chat application, I don't need to consider things such as polling or open up WebSockets. GraphQL and Amplify allow this to happen for me. It comes with multiple frameworks, Ionic, Angular, and Vue. And the CLI toolchain and UI components are all built into it as well. One of the fascinating things, you can actually build up your GraphQL APIs, which is a way that your front end can talk to your back end. It's like REST, but with extra functionality. And also, you can have multiple different data sources. So people can use things like DynamoDB, any RDS instance. You can use Lambda, so you can talk to a completely custom data source, or other HTTP endpoints. And one of the things that I found really difficult when I was building an application was authentication. And this now is available at just a single command line, and you can build in an authentication layer to your applications and your websites. So the components, the UI components are made up of 3 different types. So you have the different color schemes. So the themes available for you, so you can pick and choose easily to create something that's going to be desirable for your users to use. Typography, having that consistent text all the way through. It sounds simple, but when it's done correctly, it feels like a much easier application to use. And the components, so they get built together. So you're able to have dialog boxes, confirmation boxes, tooltips, notifications, just out the box, and you only fill in your content rather than trying to design something custom for your needs. So when we talk about the cloud services, really we're now talking about everything inside of AWS Cloud. And some of the common ones that people would start to work with would be Cognito. And this is what we provide for authentication. It allows you to do authentication through other providers, such as Facebook or other social providers. Then it has all the different data sources. So we touched on them before, but Lambda, DynamoDB, relational database services, or the HTTP endpoints. And then when you're starting to build this, you want to be able to understand what your users are doing. So Pinpoint is a way of sending targeted notifications to users by it understands what your users are doing. And then Amazon Kinesis is a way to be able to ingest all that information that comes from your users, and then you can act on it in any way that you like. Excuse me. On top of this, we have different API layers. So you have the API gateway, which is, if you're building a REST API, this is a simple way to be able to host your API. You can import a Swagger file, or you can create your paths and your resources with your different functions, either to get, post, or delete. S3 as a storage layer is one of the most flexible ways that you can store data. It acts as almost a NoSQL database, and you can store virtual infinite amount of data on there. Lex, we touched on before, is the ability to integrate a chatbot into your application, again, just through the command line library. If you're building anything in the augmented reality or the virtual reality space, there's libraries there that make this faster too. And with many mobile applications, you want to notify your users using push notifications, and we have the pub sub section that also works with IoT devices. So AppSync works at its best with GraphQL. They work very nicely together. So is anyone familiar with GraphQL in the room? A couple of people, so I'll expand on it for everyone else. GraphQL is a different way of building a REST interface, a REST API. So an API is that interface that machines will talk to each other. When you're building a REST API, you specify exactly what the method looks like, what it accepts and what it returns, and then people or users or systems will call that and get the information back. With GraphQL, you're able to give your clients a query-like interface where they can choose the data they want to have come back. So they can say, oh, I'm a mobile application, I want to have less information than this website. Or I'm actually interested in a slightly different functionality and I want to join these particular data sources together. It allows you behind the scenes to put different data sources. So it acts as this orchestration layer and deals with the offline programming model as well. So the key thing here is because you're not, you're able to move quickly because you're saying to your front end, I don't mind what you do with the data. You can do anything you want. Here's all the data sources. You can lock down the controls. It means that people that consume your API can move really quickly. And when you're building your MVP, one of the most important things is the speed that you're able to build it at. So with the tooling itself, Amplify gives you the ability to set up different development environments. So there's two different scenarios on here. One is, as a user, I have different environments for my development, test, and production. You can even give different developers their own environment so they can build and create into that. Or you can have environments that your developers can touch from each of them. And this makes it really, really easy to be able to have stable test, development, and production environments without causing any breakages across them. AWS Amplify Console, if you go through the console that we have, you'll see it has a couple of really interesting options. You can get your domain name set up really easily. It has the workflow so you can build your application. When you commit it, it builds it and deploys it. You can have different deployments for different branches so you can see what it looks like. It actually renders an example of your application, your web front end, so you can see what this looks like, and you can always have a sanity check before you push into production. And then if you've got development environments, you can just simply password protect it. This is a really easy way to be able to bring up a website, have all that feature, functionality, and control over who can see it. From the CLI perspective, it's a tool that you download and you'll run from your command line. And to add an API, it's as simple as this. You call the Amplify add API, you define your model, you specify if you want any authentication, what the fields look like, and then you specify how it should get the information from there. That's the simple to-do list. The CLI actually has many different commands alongside of it. So to set up a product, you use init, which will build and set the base structure for you. You would then select your libraries, whether you want JavaScript or any other languages, any front-end components you're interested in. You build a mobile, web, or anything else. To add authentication, it's as simple as add auth, and then you'll just fill in the form on the command line. Analytics, APIs, exactly the same way. Then to deploy it, once you've made your changes in your code or your configuration, you just call a push. And that is then pushed up to the cloud, and it starts to deploy and is ready, available for you. So cool. We've now just built a mobile application, a website, an API, and we're able to get that done really, really quickly. We have a couple of demos that you can workshop that you can work through in under an hour if you're kind of focused on it. But you want to be able to measure. You want to know what's going on inside the application. So of course, you need to be adding the analytics, but there's extra tooling that makes this easier for you. So many of you hopefully will be using dashboards to understand what your application is using. And QuickSight is our dashboarding tool that allows you to ingest any data that you have, create queries, and display them graphically to your users. The nice thing about this is this can also be delivered via email. So does anyone give investor updates to any of the investors or interested parties? Yeah, that's a really common practice. You'll start saying what you've been working on, what's going well, any key metrics. And a way to do that automatically is just have these dashboards delivered to key sort of parties that need to know about what's going on. Or you can have it delivered to your team so you can daily understand how things are affecting your revenue, or if it's affecting your click-through rates or time on application or the metrics that you care about. It's really important to get that figured out correctly. Or you can, in fact, offer these dashboards inside your application. Now, this may be part of your offering because you might offer some sort of analytics tooling. Instead of building your own dashboard, you can take that very same dashboard and drop it inside your application. And that's really easy to do. It's just 4 simple steps to achieve this. Some of the really exciting things you can do are the ML-powered dashboards. And what these do is they're able to give you anomaly detection. So if anything strange happened across your application. So one of the best ways to know if there's any malicious users is by looking at anomalies. Or perhaps there's users doing something you didn't know about. And when you discover what that is, that could be a new, valuable either market or product or feature that you can start to build out. It also gives you the ability to do some forecasting, to start to predict what this product could be worth over the future and how things start to progress. We see machine learning be used more and more and more inside of the phase of measurement. To measure is to be able to pick up all the information that happened before, but with machine learning, you're able to take that information and then do a data-driven prediction on what could come next. So to go into the anomaly detection a little bit more, this is an example of what it looks like. It not only detects the anomaly, but gives you a little bit of an explanation around what's happened. So here you can see like a large uplift, and it's highlighting to the user, this is an unusual behavior. And then people can dig into it and understand. Now, as a person, possibly we're able to see this quite easily, but have it done programmatically, it means that someone doesn't need to understand all that business context in your dashboard to understand that something is interesting. And it alerts you what happened and why it happened. These alerts can also be delivered by email if you want to receive it that way. Versus of course, yeah. So I'll just repeat so everyone here, just in case. So he's asking, is it more efficient with some types of data than other types of data? With the anomaly detection, it's able to look at anomalies typically through a very common anomaly detection algorithm is random cut forest. So it's going to work really well on numerical data. So if you're doing it with textual data, it's not going to necessarily understand what that detection is. Then when it comes in specifically what type of data, it really depends. The key thing is it learns off your data streams. So if you were considering financial data, they could be completely different for different businesses, but an anomaly would look different in each scenario. Cool. So forecasting. Like one of the really things that we want to know more than anything is what's this going to look like in the future? Where can this possibly grow to? Now, of course, this is built machine learning to allow you to understand where you could be growing to, and you could do trends and then extrapolate them outwards. And it detects any seasonality trends inside of it as well. Of course, the way startups grow, and you might not have too much data, this will only it will get more reliable over time as you start to use it. And in many ways, I would set yourself a challenge of, this is what we think the trend is, can you grow faster than it? Like keep that ambition that you always will have. So now when we talk about iterations, so if you imagine we've built our product, it's out in the world, users are using it, we've gone one step further, we've measured it. We've understood what people are doing, we've even made some predictions about what will happen. The key thing then is to be able to say, what do I do next with this? How do I take this data and build something different or improve on what I had? And I would say that the iteration phase is more or less the same as the build phase. But you want to be able to take that original component and have built it in such a way that you can move quickly through it. So if we go back to Amplify again, you can add a large number of different functionalities and features. So we touched on analytics before, and the API also. The authentication itself is super valuable, and it allows you to create, so maybe you'll extend it, and you would have had just users before, but perhaps you now realize you need different groups of users. You might need managers, admins, and view-only users. These are easy to add and create this way. You can create Lambda functions by calling the function, Amplify add function. Or you can create hosting to be able to create a website and have it available for you. The interactions would be like Lex interactions or the text-to-speech, and these can again be created in this exact same way. Notifications are a really powerful part of the way, one of the biggest changes inside of the way people are consuming things. Instead of having to do a request and response, I can get them sent to me. And we have many different types of notifications. So we have the SMS, so a text message sent to your phone, the mobile push for Android and iOS. Also the notifications such as email that could be sent via an email to myself. One notification could spawn out many to do this process. Internally, notifications are used to communicate between different services. Perhaps I've got a service that I want to act on and then notify other services. And you can use HTTP push or simple notification service internally to alert another AWS service or even a custom service. And the different types of storage and database options are always ever growing. So S3, again, I really call out as one of the most important storage options that we have that people are able to build on, and it acts just like a REST interface. If I put a JSON document inside of S3, I can reference it just like it would on any other endpoint. So what I would say when you're thinking about iterating is you would have set an expectation with your users of this new awesome way of doing something. But that expectation is never going to stand still, continually evolving. So what people are wanting, instead of just like, here's all the information the same as everybody, is personalization. You ideally want me to be speaking to each of you individually and explaining things. And that's what we do outside with the Ask the Architect. And we don't want to have these devices that don't understand that I was using the same application or website on my phone, laptop, and PC. And the traditional way that we interact with machines has changed drastically since machines were ubiquitous over the last 40 years. And in this period as well, it's changing again. We went from a browser to a mobile application, and now from a mobile application, we're starting to think about voice and text communication. So the ability to support that. And one of the mistakes that I think is a disservice to users is focusing on what you want as a business rather than what your users are trying to achieve. What is the job the users are doing? So creating these experiences that are focused in on each of these demands of your users allows them to get better value from it. If they get better value, you're able to iterate quickly. In Amazon, we talk about a dissatisfied customer. And what that means is it's a customer that's demanding, they're asking us for more. Now that's a good thing for us because it allows us to continue to iterate on their demands. And once we're able to satisfy this customer, we want them to be dissatisfied again, to keep pushing us further. And these are the sort of things that you can build and start to understand with some of these experiences. So to make this happen, we have a couple of things that really help. So the first is getting that message to your users. So we spoke about SNS, and the ability to send the email, text, push notifications, and even voice as well now. With Pinpoint, you can target your users. You can say that you want to deliver specific messaging or push message rather than to every user. You can target that to different segments or different times a day. And you can deliver this message in such a way that it feels personalized. You're not treating every user the same. And you can go one step further. You can get even deeper with the personalization that you would do. Instead of Pinpoint creating segments, you can use machine learning with the data that you'd get from Kinesis to have this continual flow of information. From that, you're able to create personalized experiences, and you can store this profile data and then act on it in different ways. And that can be through triggers of events, or you can have different messaging that's targeted at the time of day or the context that they're working in. Maybe your application is best used as you enter the vehicle. So it's not so great to send that as a blanket time. It's when they're moving. Or perhaps it's when they're achieving a certain task or at work or thinking about food or listening to music. So what I'd say is focus most importantly on the speed that you can iterate. The speed that you can iterate is super closely correlated with the cost of your iteration. So focus on the interactions that your users have. And there's a lot of different algorithms, whether just standard algorithms or machine learning algorithms, to help you work better with this. You can build machine learning models that start to take some of the data that you have collected from your users. You can use SageMaker to start build up an understanding of what's going on. And we don't share this data with anyone, of course. This is your data that you're able to build, iterate, and work better with. So you can then use what we call the predictive user engagement to describe how that you would work with your users. So this is really simple architecture that I'll just kind of step through so you can understand. So you'll have different access points for your application, your web, mobile, etc. And at the end of it, you want to have personalized and different notifications. So Pinpoint is the entry point that's able to kind of segment and send them notifications. It collects the data from your users. This is then pushed to Kinesis. And you may have different functions. We call it an ETL function, and that's designed just to take that data, reshape it, put it into another system. This is really common because you might need to grab data from another data source to understand more about this user than what they're giving you through their interactions. Once you have this, S3 is a great place to store it. It's cheap, it's reliable, and when you're starting to do machine learning models, you're able to pull in as much of that data as you need and then run algorithms over the top of it. So Amazon Personalize is a service that builds up a personalized understanding of your users. You're able to then use this service and present different user interactions, whether that's messaging or experiences, workflows, or results, or even potentially the UI. You could slightly change the way that's laid out. And this, yeah, the personalize. Yeah, so Personalize itself is a service that is able to create different, like Cheyenne was speaking earlier about the website. We change it 100 times a day. And we actually changed it based on people's objectives or the type of user that they are. And we do this by segmenting the users and understanding the differences between myself, yourself, and anyone else in this room. So Personalize is, it's a little bit like a recommendation engine. And it's kind of understanding the nuances between us. So this architecture here is kind of taking your user information, bringing it through Pinpoint, which does some segmentation, storing it, supplementing it, and then using Personalize to then try and isolate what's different about you. Now, we can't tell you what to do about what's different, but we can give you that information. And then you're able to build your interactions. In this case, it's really focused on the personalized notifications. So different messaging, whether that's time of day, activity, different promotions that you may have. Okay, so if you could imagine, if you were able to build something, iterate on it, and then measure what's going on. Sorry, build, measure, and iterate. And you're able to continuously loop through that. You're going to grow very quickly. Like, you know, in a way, some things are simple to describe and incredibly difficult to do. And this is exactly one of these things. And when you get to the scaling phase, a lot of people, when they're building a startup or building an MVP, they're thinking about, oh, what happens when it scales? And it's a completely valid question, but it's almost the wrong question to ask at that time. Like scaling on cloud computing or AWS in particular is actually really easy compared to building a company and building an MVP, iterating and understanding what your users want. So what I really say, I'll touch into this section, but really the first part of this talk, kind of from here onwards, is the most important part. Like figure out the way, understand your hypothesis, figure out how to build it as fast as possible. Had someone ask me earlier, what programming language should I build my application in? The answer is different for every one of you. It's which one you know the most, which one you think you can move the fastest in. There's no single language that does it all for you. Make sure that you're measuring. If you're not measuring, you don't know what's going on. Now, things might be going great, but you don't know why or how, and you don't know how to adjust it. And then the ability to deliver continuously on these things, the people, the things, and the features, and the demands of your users. So with scale, we have many different options. If you think about how that we manage scale at AWS and the type of offerings that we make available to you. So from a compute point of view, we have broadly a few different options. So one of them is the container services. And containers have had incredible growth over the last few years, and people started to use them for all manner of things. So we have different layers of container services inside of it. We have two managed orchestration services, Elastic Container Service, ECS, and Elastic Kubernetes Service, EKS. And the biggest difference between them is, well, one is Kubernetes based, and that's the product that many people know and love. And the other one is ECS, and this is fully integrated into the platform, and many, many customers are able to use this and iterate on with it, and it integrates with things like CloudFormation and all our IAM policies as well. Now, when you're running containers, there's still servers and infrastructure that happens behind it. And that's one of the things that when you start doing it, you start realizing you're starting to scale that up and out. So the most common way of doing it is using EC2. So you have EC2 boxes, you'll run a container orchestration over top of them. That orchestration will place the containers where it needs to, and then you'll scale the containers underneath. Fargate removes that problem for you. What you just do to say to Fargate is, I need 10 copies of this container with this much CPU and this much memory, and it will go and provision that on a fleet of EC2 instances that we maintain for you. So you never need to think about the scaling underneath that happens. And when you're building containers, typically you'll use Docker, and you'll need a container repository. So there's a lot of public containers available inside a Docker Hub, and we have a container image repository that's compatible with both Kubernetes and ECS that allows you to store your containers inside of it. So a really typical workflow is you'll commit code. From that code, it will go build do some unit testing, build your application, create a container, and then you're able to deploy it inside of any of these environments that you see here. The other really exciting way of doing compute is serverless. So if you were to go one step almost beyond containers without thinking about what I need to manage, a serverless is a container of sorts. It's running code, and the code is broken down even more tightly for you. It's done at a function level. So you would, instead of building an application that does many different things, with serverless, we take it so that it is a function that ideally achieves one single task. You can then attach this serverless function almost anywhere inside the console. So it can live off the back of a notification, so an SNS notification. It could sit on the back of a API gateway call. It could sit on the back of GraphQL as well. It can be the glue between when a message arrives in S3, a notification is fired, a Lambda calls, changes that message or changes the file in S3 and then does something else. So serverless is many times referred to as the thing that ties together many of these functions. And people build microservices on serverless. And the fascinating thing about that is you only need for that function the libraries that that particular group of code needs to run. So if you think about your applications, if you're building from a framework, you've got 10 libraries, 20, 100. Maybe they call many other libraries as well. But for each function, you probably only need one or two. So you're able to package up tiny, tiny deployments. And then when you don't need that particular code or function, you just delete it. And there's clear separations in between. Some of the really exciting stuff here is it's automatic scaling. You don't need to think about how this scales up and down. It has 100 millisecond billing, so if you write efficient code, it's cheaper for you. So you're directly tied to the value that you create as a programmer and what you have to pay at the end. And of course, it's available and secure for you and your users. Now, when it comes to the different services that most people are kind of focusing on here, so you've got your compute and your data stores. We have a wide array of data stores, actually, and this is just a little subset and some of the integrations that come in place. So let me go into some of the database and data storage stack that we have. And you can think of databases and data stores and analytics almost together. There's a large crossover, and the real difference is the data's shape and access patterns. What I mean by that is, are the files big? Are they related? Are they structured? Are they semi-structured? And how often are you accessing it? Are you writing more than you're reading? Is this a log? Are you reading more than you're writing? Would a cache be a good idea? Do you read sequentially? Are you stepping through things one at a time? Is this completely random reads? Or is there hotspots? I'm always checking this particular place out rather than other ones. Maybe that changes over time. So here are some of the tooling that we have. So if you start at the top and think about the intelligence and machine learning, we have the machine learning service itself. We have SageMaker and a large stack across the top of this that you're able to take your data, build on top of models, and then deploy them out into the real world. QuickSight, we looked at earlier, which gives you insights and information and graphical displays of what your data is and what it looks like. From a relational database point of view, we have the RDS service, which has multiple databases underneath. But for me, when I work with startups, the most common databases people use are Postgres and MySQL. And they're actually both supported in Aurora. And Aurora is a way of scaling your database without actually needing to break away from your Postgres or MySQL database. It gives you increased performance and more efficiencies. Then from a NoSQL or non-relational database, maybe is a better way to describe, we have DynamoDB, which is an extremely reliable, low latency NoSQL database that's able to scale to any amount that you need. And Elasticache or Memcache, so Elasticache has Redis and Memcache inside, and it acts as a caching mechanism. But Redis itself, many of you used, I spoke yesterday to quite a few customers, and a lot of them were using Redis to work as your data store, and many people use it that way. Recently, we announced what we call DocumentDB, and this presents to a user a front end that looks and behaves exactly like MongoDB. The really cool thing here is we have a lot of experience on the storage layer. So we present to you MongoDB, just like with Aurora, we present a MySQL or a Postgres database. Behind the scenes, we will work differently. We have created cloud-native data stores to allow this to work faster and to scale and be more reliable. But as far as your front end is concerned, it's talking to a Mongo-compatible database or Postgres or Postgres or MySQL-compatible database. From the analytics space, Redshift is our data warehousing. So we're able to build up scalable data warehouses that also take into account large amounts of data you don't read from very often, or data that you read from really often, do a lot of data graphing and storage. Interestingly as well, you can then use Athena. And Athena is like a query layer that runs on top of different data sources. The most common one is S3. So what a lot of people do is they'll store their data in S3, all that analytics data. Imagine all that clickstream data. One thing I forgot to mention is every time you use a service, turn on the data access logs. If you turn on the S3 logs, the API gateway logs, and any other service logs, you've actually got an incredibly rich view of what your users are doing. You can store them in S3, and then you can analyze them or do machine learning over the top. For the real-time analytics, there's two different things in here. So Elasticsearch gives you incredibly detailed and scalable metrics. So you can put your data into it, you can run queries over the top of it and have good insights of what's happening. And Kinesis is that pipe where you can send as much data as you want into it. It's great for ingesting data if you've got telemetry data from your devices or other information your components are communicating. What you can then do with this is you can store it off into S3, you can run analytics, and with that it gives you the anomaly detection, similar to what QuickSights gave as well. And that's great for understanding perhaps there's an outage, or perhaps there's a huge spike in interest in a certain product line, or something you need to be aware of. And then as well, you can attach Lambda functions to it. Perhaps you want to have a completely asynchronous view, asynchronous process. So when your data arrives, you can have different Lambdas reading from it, or even EC2 instances acting on it, and then pushing the data somewhere else. And for a data lake, so S3 or Glacier for your really cold data, Glue allows you to take that data, change it into any different shape. So it's really good if you've got data in a relational database and some in S3. You can run jobs over both of them and put it into the same format. And that is then pushed into your perhaps machine learning or dashboarding or QuickSight dashboard, sorry, or your data warehouse with Redis. Macie itself is a really interesting service. What it does is a lot of users really care about their privacy and how you work with their personal identifier information. And Macie scans over the data and lets you know what could be potentially personal identifiable information. So it allows you to either delete that information or put extra permissions around it, or at least you're aware of what you've been given. So customers use that in different ways. They either use it to kind of do an audit of the data they have, or they do it to make sure that customers aren't accidentally giving them data they didn't want, if it's like a document storage, something they shouldn't see. Or if you actually need to hold this information, you then build really tight controls. And using IAM and minimum permissions and separate accounts, you can make it that even your administrators can't see the inside of data that's stored on your platform for security reasons, especially when you use encryption. So I'm just going to leave you here with just an example of a simple API service that actually can scale to any volume that you need. So the most common way of doing it is CloudFront in front. So CloudFront can actually sit in front of your API. What many people realize intuitively is that a CDN, which CloudFront is great for a website. You can cache everything there, and you can push things out. Things arrive faster to your users. But a REST API endpoint operates in the same way as a website. So CloudFront can be used to cache actually your website. There's a couple of caveats. Of course, you need to think about, if I'm doing a GET, how long should I be caching that information? Maybe it's 0, maybe it's 5 seconds, maybe more. It then allows certain users, if they're in distant locations, to take advantage of the speed of our backbone to get faster requests. When you're doing puts, posts, and deletes, you should not cache them, naturally. But many API calls are gets, and these typically are cacheable, because if you think about it, it powers a website, and you would cache that. Then from behind the scenes, API gateway it can have its own cache if you want to have business logic at that layer. But you can also attach API functions. You can push it to any other load balancer that you may have in your system. And that could be hosted on EC2 inside of any container service that we spoke of. Or we could even directly call different services. It could call Elasticsearch and present a search results straight to your users without you having to write any additional code. At the same time, it could call into an S3 bucket. If you can pre-process your results for certain queries or certain product descriptions, you can create a JSON file that lives in S3, and when a user comes, they don't need to do a query on the database, which is expensive in time and cost. And then, of course, API Gateway can talk to any other AWS service, as you can imagine. This can then be hosted inside your own VPC to keep the security and the controls that you would want for yourselves and for your users. And then you create these public endpoints so you can control who has access to it.